Well, good afternoon. We'll see if this, hey. Good afternoon. My name is Jerry Towler. I work for Southwest Research Institute, which is an independent, nonprofit research institution in San Antonio, Texas, which means that I kind of came to Madrid expecting some of the food to be familiar, and it turns out the Spanish and Mexican food is far more dissimilar than I expected. I am excited today to get to introduce to you guys a project that I've been working on for several years, and one that I think is pretty exciting development in terms of ROS and in terms of robotics in a community that doesn't really traditionally work the way that this open source sharing community does. It's called ROS Military, or ROS-M. And I'm going to tell you about it, but to give kind of a motivating example, I'd like to start off with this. Have you ever gone to the grocery store and you get to the salsa aisle, because in Texas you have a salsa aisle, and you can't remember if you have salsa at home. And you've got all these chips in your basket. You can't remember if you've got any salsa for them. And it's going to be a travesty if you don't, because they're going to send you, back to the store. And in Madrid, it's like a 4-minute walk down to the store, but in San Antonio, it's like a half-an-hour drive out there. So you're not going to get back in time for the second half. So you go ahead and buy one anyway, and then you get back to your house, and you look in the pantry, and there are like 12 jars of salsa in there already from the last 12 times you went to the grocery store and couldn't remember whether you had salsa at home. Engineers, we kind of work like this. You are kind of thinking about something that you need, and you can't find it immediately on Google. You can't find it immediately on ROS Index. You type, sudo apt install ROS kinetic automated vehicles, and nothing really comes up. So you go ahead and say, look, I'm going to just start from scratch. I'm going to build my own automated vehicle. It's going to be awesome. Unfortunately, building an automated vehicle, as a number of people in this room know, it turns out to be an incredibly hard task, where incredibly hard is measured in millions and millions and millions of dollars. So if all those jars of salsa were like $4 million, you'd be really careful about whether you had some already at home. But it turns out, right, that it's not enough to know how much you've got. You also have to know, which brands of salsa go with which chips. You have to know which people who are coming over to watch the game with you are allergic to these particular ingredients, or that like these particular ingredients. You have to pay attention to all of these different things and kind of make sure that you know what's going on in all of them, which salsas are appropriate for which situations, and which ones are available when which groups are coming over. And so you're an engineer, so of course you pull out your spreadsheet and you make a table. This is a table of salsas. Obviously, you need to rate them according to whatever your metrics are. But this talk is not, of course, actually about the rating of salsas, although, again, as a, I guess, Texan at this point, I guess I could do an entire talk on this. Instead, our table is much less delicious. It looks like this. So what we have is a list, a spreadsheet of ROS packages, of robotics packages that are in use by the US military. And the basic premise behind this is that it turns out that there are two kind of big problems with robotics within the US military infrastructure. And one of them is the salsa problem that I mentioned, which is that you don't always know whether this particular salsa is appropriate for this particular application, and so you just buy another one. You build from scratch. And that's something that obviously is incredibly expensive and is not really something that a lot of engineers love to do. You don't want to start from scratch. You want to move on to the cool new stuff in automated vehicles. So we'd like to enable that. We'd like to enable it in a context, and this is the other part, a context that is not really used to the open source philosophy. A context where, in general, everything is closed, everything is proprietary, everything is walled off. And so ROS Military, our goal is to remove as many of those barriers as we can. Now, I want to kind of make sure that it's clear at the beginning here that we can't remove all the barriers. We're not just going to start posting things on GitHub. Unfortunately, you're not going to be able to download a automated tank. But actually, maybe fortunately, you can't download an automated tank. However, I want to say now, and I'll say again at the end, that one of the goals of this project is actually to work with open robotics, work with the ROS community, and be sure that we are actually benefiting the entire community, that we're not just staying within this kind of walled garden. Because even if we can break down a lot of the walls within the US government, US military infrastructure, let me tell you, that's going to be a success if it turns out that this works out the way that we are hoping and the way that it looks like it's going to. But we'd like to make sure that we're also opening up to the world wherever that's possible. So I'd like to give you a kind of a brief history of ROS Military, something I've been involved in from the start. I want to be very clear that this is by far not an effort that is just mine. There are a number of people in this room. There are an awful lot of people all over the world. There are dozens of organizations and lots of people who are part of this effort. It just happens that I'm the one talking today. So I want to be clear that this is not just mine. This is definitely not just Southwest Research's, but it's an awful lot of people behind this. So it started in 2015 when we kind of looked at the state of military robotics and specifically automated vehicles, and we said, well, you know, UGVs are being asked, that is unmanned ground vehicles, being asked to do an awful lot of tasks, an awful lot of work. And we're asking more and more of them every day. And whenever we have a new application, we have to build a new robot. Wouldn't it be nice if we could just build the robot once and add new features on top of it as we went? Like I said, military tends to be kind of a walled garden, and so when you build one feature, it tends to belong to you, and then it's hard to integrate that feature onto a different platform. However, we at Southwest Research had some experience through a sequence of projects. We'd had some experience with doing basically exactly this with a technology that we call the Robotic Technology Kernel, or RTK. This is a base autonomy mobility platform based on ROS, entirely based on ROS, except for the tiny piece at the bottom where you actually have to drive the car. This is something that we had worked on through the Office of Naval Research and now through U.S. Army TARDEC, both of which are research organizations that enabled us to move from vehicle platform to vehicle platform with relatively minor reconfiguration, enabled us to add new features on top of it with relatively minor modifications to the base vehicle platform, and as a result allowed us to incorporate new demands, new desires from some of our clients a little bit faster, in some cases a lot faster than you might otherwise expect, especially when you're used to military projects that are measured in decades instead of months. This picture right here is one of the vehicles that we've used. The picture itself is not necessarily important, but I felt like I needed a picture to go with that one, so I did. And the next piece of this, so these are two pieces that kind of came together to make ROS Military something that we knew would be useful. The next piece, of course, is ROS itself. Generally, when I give a talk like this, I generally have to sell people on ROS and explain why ROS is a good idea and all the benefits that you're going to get out of it. So I'm really hoping that that's not necessary in this room, but it's an important component of what's going on here because it gives us kind of this base common framework to work against instead of, company A using their framework, company B using their framework, and then it doesn't matter how open source you are, there's no way you're going to talk to each other. And so ROS is really an important piece here. So we spent a little while kind of doing what we called a concept definition, making sure that this is actually a feasible project that is, that is going to work in the first place, because if we're going to spend time and effort and money on this, we want to make sure that this is actually going to be accepted not only by our government clients, but also by the industry itself. And so we spent a little while kind of figuring out what we wanted to do, what we were going to do, what would be most useful, and then how maybe we could do it within this context that I've talked about before. And then we spent a year asking people a lot of questions. We wandered into the military industrial community, the robotics community, and we talked to everybody we could get our hands on across the US government, not just within the military, but reaching out to other organizations like NASA that's been here this morning. And talking to them about, what would be useful and how would this work? Talking to industry partners and saying, hey, how could this work? Understanding that you have your own intellectual property considerations and your proprietary software considerations and, frankly, your profit considerations, which is something that we're very aware of, obviously, even, despite our nonprofit status. And we got some answers. So at the beginning of this year, we put together what we called a prototype, which is basically just throwing together a proof of concept for everything that we've done so far. And I realize that this is a conference where a lot of what we talk about is kind of software-based, sometimes it's hardware-based, but what I'm about to talk about is going to be a little bit more process-based, because it turns out that the hard part about building automated vehicles for the military is not actually the automated vehicles, despite that those are incredibly challenging, and we still haven't solved most of the issues going on there. There's lots to go. It turns out that the hard part is everything else. And so I'm going to talk a little bit about what's going on there. I'm going to start with this thing, the infrastructure that we needed to put together for this. So if you're going to figure out, if you're going to figure out how much salsa you've got left, you need to make a list of all the salsas that you have. If you're going to figure out what robotics capabilities you have available in your arsenal to bring to bear against a new application or a new mission, you need to make a list of them. We call this list a registry, partly because it sounds a little bit fancy, and partly because this is a heavily metadata-rich repository of information. This is a place where we want to gather as much as we can about each of the robotics projects, each of the robotics packages that are available, and then present that to the end users. Now this presents a little bit of a challenge because in large part we kind of don't want to tell anybody else what we have available, because we are afraid that they are going to go take it and they're going to build it themselves, and then they're going to sell it to our clients instead of us. And by we, I mean everybody in the industry, right? So this is a little bit of a challenge to begin with. But we've made a start on it. We've built some infrastructure, some back-end. We've taken a lot of cues from ROS-index. We really appreciate a lot of hints from there, what was going to be useful here. Unfortunately, we've then hidden this behind some authentication requirements because, of course, we are U.S. military, and so we can't, unfortunately, cannot just open this up to the whole world. But we've built this registry. The repository is kind of an interesting example. We wanted to make this, like ROS is, federated. Sometimes you are willing to open source your contributions. Sometimes you want to say, yeah, everybody can use this. Sometimes you want to keep that in-house. But even if you do want to keep it in-house because this is your secret sauce, this is your competitive advantage, we need to know about it. We in ROS-im need to know about it so that we can go in and contact you and license your software for our new application. So in those cases, of course, we want you to host it wherever you want to host it. But if you don't, if you've got somewhere else that you want software to be hosted that is not necessarily public, but is public to this certain group of people, we've got a repository set up on some government infrastructure. And then finally, the metadata here is, like I said, this is a rich trove of information about each of these packages, talking about what it works and how it works, but also, as we've heard a little bit before, about testing and certification. This is very important in safety-critical applications like automated vehicles, and especially in military automated vehicles, where the whole point of taking the soldiers out of the car in the first place is to protect them from danger. We don't want the car putting them into danger itself. So safety is an important aspect here, and the metadata helps us understand exactly what kind of certification process everything has gone through. And then we said, well, we've got to actually try it, right? So we took one of Southwest Research's path planners. This is Maverick. This is an RRT star-based path planner that had an IROS paper last year. If you want to go know more about it, it's super, super fast. And we converted it into ROS2. That was a little bit harder in January than I expect it will be in December, but we went ahead and did it. And then we integrated it into RTK, and we put all of our, whatever it is, 200-some packages together on a hybrid ROS1, ROS2 system and drove an automated vehicle around. So it turns out, as we've seen already today, that hybrid ROS1, ROS2 systems work just fine. Which is really nice for us because we didn't have to do the entire vehicle. And then I wrote formations up here. There was another company that worked with us during this that also took some code and converted it to ROS2. So I don't want to say, this is just Southwest Research's thing. This is as collaborative as we can make it and as open as we can make it within this context. Another piece that we wanted to kind of focus on that's very relevant to pretty much everybody, but especially to the military, is cybersecurity. We're not going to solve cybersecurity ourselves. You guys have seen lots of presentations already today about security within ROS2 using DDS. ROS-im requires ROS2, by the way, to be listed in the registry. This is a requirement for us, largely because of the DDS capabilities and what we can get out of that that's not available in ROS1. But because we're not going to solve this ourselves, what we want to provide is kind of a bottom level, kind of a floor on how much we're going to get out of all these software components to make sure that everybody is following a list of best practices, so that every piece of software is as good as we can make it, and then at some point, of course, you have to put in the effort to really get it tested and certified and all of that sort of thing. But we want to make sure that everybody has some base level of capability. And then finally, and here's the hard part. So all that kind of sounds hard to me, or at least having experienced it and done it, it was very hard. This part is actually 1,000 times harder than all of the rest of it. This is the business aspect of ROS-m, and this is figuring out how all of this is going to play out in the context of lawyers. And it turns out that intellectual property is hard enough when you're not dealing with a government. When you involve a government, intellectual property becomes incredibly challenging. Contracting becomes incredibly challenging. Lots of things that are relatively easy, or at least simpler in some contexts, become more challenging. Well, that's not a really good recipe for adoption of something that people don't really want to adopt in the first place. And so what we wanted to put together, and what we have put together, is what we call a business guide, which is, this is how you can incorporate ROS-m into your application. This is how this can work in a context where you're used to buying a complete package, a complete vehicle, a complete piece of software, and having it delivered to you, wrapped up with a bow. This is how ROS-m, which looks like open source, and in fact within the government context will be largely open source. This is how it can work out in your field, in your mission. And so we put education up there as well, because as I'm sure a lot of you who work for larger corporations know, working internally on adopting open source philosophies, on being able to open source software that you've worked on yourself, is not always just a checkbox. A lot of times it's an uphill slog, and this is something that we want to help people do. We want to be part of that process so that we can bring some resources to bear for folks who perhaps don't have all those resources for themselves. So this is what we've put together so far, and I wanted to talk to you all about it because ROS has, of course, been crucial to this, but I personally really appreciate a lot of the niche groups within ROS that have kind of paved the way for things that ROS-m looks like. ROS Industrial was a huge inspiration for us, taking the idea of these commercial robotics manufacturers who, again, generally in their context, were not really big on sharing, and managed to figure out a way to drive them towards the open source philosophy. And we really love that, and we wanted to share that we are doing the same thing in a wildly different arena. And so far it's going very well, and we're pretty excited about it. So here's the final piece of it. Expansion. So I talked about defining the concept, figuring out what we're doing, building our spreadsheet of salsas. Stakeholder input was asking a bunch of questions. Initial prototype is what we just did just recently. And then what are we doing? So in classic open source form, we really want to push this as far as we possibly can. We really want this to be across the US military, and if we can, across the US government. This is something that is applicable in a lot of arenas that are not just military applications. We've seen nuclear applications already, for example, and you can imagine why governments might be interested in those. And so this is something that we want to open up as far as we can. We already have a lot of partners on board through various consortia. Open Robotics has been on board from the very beginning, and of course that's a lot of connections into a lot of folks. But if this is something that applies to you and you want to learn more about what's going on, I'm here obviously today and tomorrow, and I'll be at IROS all week next week, and I will be happy to chat with y'all. If you won't be at any of those things, here is an email address, and I'd love to talk a little bit more about it. Here is our lovely ROS-m logo, which is apparently cut off on y'all's screens, but on my screen it looks really nice. It has actually 3 full circles at the top. And of course the email address is also cut off, so that's really exciting as well. But anyway, I guess you should just come find me. And with that, I'm done, and I'll be happy to take any questions.
Thank you, Jerry. Ryan, you have a question?
Yeah. Hi, Jerry. So, salsa aside, as a non-US citizen, why should the global community contribute or in any way support ROS-m? There was no discussion in this talk at all about that. And your logo has a pentagon in the middle, which is basically one of the symbols of US military supremacy.
Yeah, so the question about what's the interest of the global ROS community here, I think there are 2. First, I want to be very clear. This is U.S. military-centric, which means that it is going to be U.S. citizen-centric. So there's certainly no no two ways about that. But here's a couple of ways. One is I think that the philosophy here, this idea of bringing kind of robotics to the masses, is one that has a lot of traction in a lot of different application areas. Some of them are applicable to only certain industries. Some of them are applicable to only certain people. This one is applicable to actually quite a broad swath of industry and quite a broad swath of people. Unfortunately, they're just all based inside the United States. And so I don't think that that's a small community. I think it's a pretty large community that, for which this is a valuable project. The other one is that I think it's useful to know where ROS is being used. I think it's pretty cool for me to come to ROSCons to see things online, to find out applications of ROS that I frankly never would have thought about, that I wouldn't have been exposed to in any other way. And so this is an opportunity, at least for us, to say, hey, here's another application area, here's somewhere that ROS is being used that maybe you didn't know about, maybe is interesting to you.